Hey everyone! So I've been diving deep into the humanoid robot space lately, and honestly, what I found is both fascinating and a little terrifying. We're not talking about some distant future anymore. This stuff is happening right now, and most people have no idea how fast things are moving. While we're still arguing about whether AI will take our jobs, China has already built robots that walk like humans, cook like professional chefs, and, I kid you not, can literally carry babies to term. Meanwhile, Elon Musk is making promises about Mars robots that, well, let's just say his track record with timelines isn't exactly stellar. But here's what really caught my attention. This isn't just about cool tech demos anymore. We're looking at a fundamental shift in how society works, and some countries are way ahead of others. So let's break down what's actually happening, separate the hype from reality, and figure out what this means for regular people like us. The walking problem. Nobody talks about. Let me start with something that sounds simple, but is actually revolutionary. You know how most robots you see in videos walk around looking like they desperately need to use the bathroom? That weird crouched knee shuffle isn't because engineers don't know how to make them walk. Normally, it's because walking with straight knees like humans do is incredibly difficult to achieve. Traditional robots keep their knees bent because it's computationally easier and safer. The robot can always catch itself if it starts to fall, but this comes with massive downsides. It uses 3 to 4 times more energy than human walking, looks completely unnatural, and severely limits where these robots can actually operate. Now, a company called Kepler Robotics in Shanghai just changed the game completely. Their K2 Bumblebee robot is the first humanoid that actually walks with straight knees, just like you and me. And before you think, so what? This is a bigger deal than it sounds. The energy efficiency alone is huge. We're talking about 60 to 70% less power consumption compared to traditional robots. But the real breakthrough is stability and recovery. During an 8-hour live demo at the 2025 World AI Conference, engineers were literally pushing this thing around, trying to knock it over, and it kept recovering its balance. That's the difference between a robot that works in carefully controlled demo environments and one that might actually function in the real world. What makes this possible is what they call a hybrid joint design, combined with something called a VLA framework. That's vision, language, and action processing happening simultaneously. Essentially, the robot is constantly processing multiple streams of data to react in real time, which means it can actually adapt when things don't go according to plan. Compare this to Tesla's Optimus, which still relies on conventional electric actuators and that old bent knee approach. And here's the kicker. While Kepler's robot is operating autonomously, recent Tesla demos have been exposed as having human operators controlling the robots remotely. That's a pretty significant gap in actual capability. The butler robot that actually thinks, but walking is just the beginning. A Chinese startup called XSquare robot just raised over $100 million because they've solved two of the biggest problems that have been plaguing robotics for years: catastrophic forgetting and modal decoupling. Let me explain what these are, because they're more important than they sound. Catastrophic forgetting is when a robot learns to do something new and completely forgets how to do the old stuff. It's like if learning to drive a car made you forget how to walk. Modal decoupling is when the robot's vision, language understanding, and physical actions get out of sync. So it might see a glass of water and understand you want it moved, but the hand coordination is completely disconnected from that understanding. So it ends up smashing the glass. XSquare claims to have solved both of these with something called Wall OSS, their open-source embodied AI foundation model. What's clever about their approach is that they're training on a massive dataset that blends real-world action data with augmented generative video. This means the robot isn't just memorizing specific movements, it's actually generalizing across different lighting conditions, object shapes, and environments. But here's what really sets it apart. They've built in chain-of-thought reasoning. Instead of just following simple pick-and-place commands, this robot can plan multiple steps ahead for tasks it hasn't been explicitly trained for. So you could tell it, get food from the fridge and bring it to the living room, and it would automatically break that down into walk to kitchen, open fridge, identify food items, select appropriate item, close fridge, navigate to living room, deliver food. Their Quanta X2 robot showcases all of this with 62 degrees of freedom, 2 7-degree of freedom arms, and hands with 20 degrees of freedom each. They've even built modular attachments so it can switch between different tools, vacuum attachments, mop heads, even spinning brushes for cleaning. Now, here's the strategic part that I think a lot of people are missing. XSquare has made Wall OSS completely open source on GitHub and Hugging Face. This might sound generous, but it's actually brilliant. They're essentially creating the Android of robotics, getting everyone to build on their foundation so that the entire ecosystem becomes dependent on their technology. Any startup working on humanoid robots worldwide can now use this brain for free, which means XSquare gets to influence the entire direction of the industry. The pregnancy robot controversy, okay? Now we get to the really wild stuff. Kaiwa Technology just announced plans for what they claim will be the world's first pregnancy humanoid robot with an artificial womb. And yes, this is as controversial as it sounds. The concept is a life-sized humanoid with a built-in artificial womb that could carry a fetus through a full 10-month gestation cycle and deliver the baby. They presented this at the 2025 World Robot Conference in Beijing, with a planned launch by 2026 at under 100,000 yuan. That's about $14,000. Now, before you dismiss this as science fiction, let's look at the actual science. In 2017, researchers in Philadelphia successfully kept a premature lamb alive in what they called a biobag, essentially an artificial womb, for 4 weeks until it grew wool. But that was partial gestation. Going from fertilization to full-term delivery is a massive leap in complexity. The technical challenges are enormous. You need to perfectly simulate the uterine environment for 40 weeks, create an artificial circulatory system, provide precise nutrition and oxygen delivery that changes throughout development, and manage waste removal. The $14,000 price tag they're quoting is just for the robot itself. The actual pregnancy process could easily cost $100,000 to $200,000 when you factor in all the medical monitoring and intervention required. But here's what's really interesting from a geopolitical perspective. China is the only country publicly pursuing this research. The EU and US have strict regulations around embryo research that would make this kind of development nearly impossible. This gives China a potential monopoly on what could be one of the most significant medical breakthroughs in human history. The social implications are staggering. On one hand, this could help the 280 million couples worldwide dealing with infertility, reduce maternal mortality, and allow women to have children without sacrificing career advancement. On the other hand, it could dramatically increase inequality between rich and poor, raise profound questions about the rights of children born this way, and fundamentally change how we think about pregnancy and motherhood. The ethical debates are just beginning, but the technology is moving forward regardless, and that's a pattern we're seeing across all of these developments. The technology is advancing faster than our ability to understand and regulate its implications. Jack Ma's robot chef strategy. Speaking of implications, let's talk about what's really happening with Jack Ma's Ant Group and their R1 robot chef. On the surface, this looks like a cool demo, a 243-pound robot that can cook garlic shrimp and give museum tours. But dig deeper, and you'll see this is actually about something much bigger: data. Ant Group isn't just a robotics company. They're one of the largest fintech companies in the world, with transaction data from billions of people through Alipay. Now they want physical behavior data to go with it. A robot in your kitchen doesn't just cook. It observes your eating habits, daily routines, health indicators, and personal preferences. Combine that with your financial data from Alipay, and you have the most complete consumer profile ever created. Notice that they're not selling R1 as a standalone product. It only comes as part of scenario solutions for institutions. That's not because they can't manufacture it for consumers. It's because they want to maintain control over the data collection. Selling to individuals means losing control over how that data is used and shared. They're also developing their own large language model called Bailing, designed to run efficiently on domestic Chinese GPUs. This is part of a broader strategy to create a completely integrated AI and robotics ecosystem that doesn't depend on foreign technology. When you control the hardware, software, and data flow, you control the entire value chain. The R1 is already deployed at locations like the Shanghai History Museum and several restaurants, where it's quietly gathering data about how people interact with robots in real-world settings. This isn't just about making robots that can cook. It's about understanding human behavior well enough to predict and influence it. Tesla's Optimus: promise versus reality. Now let's talk about the elephant in the room: Tesla's Optimus and Elon Musk's Master Plan 4. Unlike the previous master plans, which were spaced 7 to 10 years apart. This one came just 29 months after Plan 3. That accelerated timeline should tell you something about Tesla's urgency and maybe their desperation to maintain investor excitement. Master. Plan 4 puts humanoid robots at the center of what Musk calls sustainable abundance. The pitch is that Optimus will take over dangerous and monotonous jobs, freeing humans to pursue more meaningful work. It sounds great in theory, but let's look at Tesla's track record with ambitious promises. Full self-driving was supposed to be ready in 2020. We're now in 2025 and it still requires human oversight. The Cybertruck was promised for 2021, finally delivered in 2024 with completely different specifications. The new Roadster was supposed to launch in 2020 and has basically disappeared from Tesla's roadmap entirely. The pattern is clear. Musk announces revolutionary products to generate hype and maintain stock prices, then quietly delays or changes specifications when reality doesn't match the promises. With Optimus, we're seeing the same playbook. The October 2024 demo that impressed so many people? Turns out the autonomous robots were actually being controlled by human operators. Tesla's current robotic capabilities are essentially elaborate remote-controlled machines, not the autonomous humanoids they're promising. Here's the fundamental problem. Tesla is great at hardware integration and manufacturing scale, but robotics requires expertise they simply don't have yet. Embodied AI, real-time environmental processing, and safety-critical systems are completely different challenges from making electric cars. Companies like Kepler and XSquare have been focused exclusively on these problems for 7 to 10 years. Tesla is starting from essentially zero, despite all the hype. The 2025 production timeline Musk announced, based on Tesla's history and the current state of Optimus prototypes, it's extremely unlikely. We might see some limited pilot programs, but mass production of actually functional humanoid robots from Tesla is probably still several years away. NASA's artificial astronauts. While Tesla is making promises about Earth-based robots, NASA is thinking bigger. Pascal Lee has been advocating for artificial astronauts, humanoid robots designed specifically for Mars missions. And unlike some of the other projects we've discussed, this one actually makes a lot of sense. The logic is compelling. Robots don't need oxygen, food, or water. They're not affected by radiation the way humans are. They can work 24/7 without sleep, and they don't suffer psychological effects from isolation. Most importantly, they eliminate about 90% of the mass requirements for Mars missions, since you don't need life support systems. Current Mars mission plans require massive amounts of resources just to keep humans alive during the 7-month journey and extended surface operations. Robots could be put into hibernation mode during transit and activated only when needed. They could perform spacewalks without bulky protective suits and operate in the extreme temperature variations on Mars without any issues. NASA's timeline suggests robot missions could begin as early as 2026, with human missions following in 2029 to 2031. The robots would serve as pathfinders, setting up infrastructure and conducting preliminary exploration before humans arrive. SpaceX has indicated that Starship could potentially carry Optimus robots to Mars, but there are some major technical hurdles. Communication delays between Earth and Mars range from 4 to 24 minutes, which means these robots would need to operate completely autonomously for extended periods. The dust storms on Mars can last for months and could interfere with solar panels and mechanical systems. And the radiation environment, while not lethal to robots like it is to humans, can still cause electronic failures over time. The interesting thing about NASA's approach is that they're not betting on any single robot manufacturer. They're developing requirements and letting companies compete to meet them. This is probably smarter than putting all their eggs in the Tesla basket, especially given Optimus's current limitations. The one robot success story nobody talks about, while everyone's focused on humanoid butlers and Mars explorers. There's one robot that's actually making money right now, Escape's AI-powered massage robot. And studying why it's successful tells us a lot about what actually works in robotics versus what's just hype. Escape has been in development for 7 years, with $70 million invested, and their robots are now operating profitably at over 100 locations across the United States. The system uses 2 robotic arms, body scanning with 4 cameras, and pressure sensors to deliver massages that customers say feel surprisingly human-like. Here's why it works. They solved a real problem with a clear business model. The massage industry in the US is worth $18 billion annually, but there's a chronic shortage of licensed therapists. XSquare charges $80 for an hour-long session, which is competitive with human therapists. And the robots can operate continuously without breaks, sick days, or turnover. But the really smart part is their business model. They don't sell the robots to spas, they lease them with a revenue-sharing agreement. The upfront cost for a spa is manageable. XSquare handles all maintenance and updates, and both parties benefit from successful operations. This removes the biggest barrier to adoption, the massive capital investment required to buy robots outright. The limitations are clear, though. These robots can't handle complex therapeutic massage or work out muscle knots the way skilled human therapists can. They're essentially doing the equivalent of basic relaxation massage. But for many customers, especially those who prefer to avoid human touch, it's exactly what they want. What's interesting is that XSquare's success comes from focusing on a narrow, well-defined task in a controlled environment. They didn't try to build a general-purpose humanoid. They built a specialized tool for a specific job. And that's probably the model that's going to work for most robotics applications in the near term. The real opportunity they're eyeing is elderly care, which is a $460 billion global market with severe labor shortages. Robots that can provide basic physical therapy, mobility assistance, and companionship could address a massive social need while generating substantial profits. The economic reality nobody wants to face. Let's talk about the economic implications that most coverage of humanoid robots completely ignores. According to the McKinsey Global Institute's 2024 analysis, approximately 400 million jobs could be displaced by automation and robotics by 2030. But the breakdown is more nuanced than most people realize. Manufacturing jobs face about 60% risk of automation, food service about 40%, and healthcare support roles about 35%. But the same analysis suggests that 97 million new jobs will be created in AI development, robotics maintenance, human-robot interaction design, and other emerging fields. The problem is that these aren't the same jobs for the same people. A displaced factory worker can't just become an AI engineer overnight. The transition requires massive retraining programs that most countries aren't prepared for. For a country like Vietnam, which relies heavily on manufacturing and assembly work, this could be devastating. The textile industry employs 2.7 million people, food processing another 1.8 million, and electronics assembly 1.2 million. These are exactly the types of jobs that robots excel at. But here's what's really concerning. The gap between countries that develop robots and countries that just use them is going to create unprecedented economic inequality. China currently accounts for 52% of global robot installations, while the US is only at 7%. Countries that control robot technology will dominate economically, while those that don't will become essentially vassals in the global economy. This isn't just about jobs, it's about economic sovereignty. If your country's entire manufacturing base depends on robots designed and controlled by foreign powers, what happens during geopolitical conflicts? We're already seeing this play out with semiconductors and AI chips. The wealth inequality within countries is going to be just as dramatic. Companies that can afford to deploy robots will have massive competitive advantages over those that can't. This could lead to market consolidation where a few robot-enabled giants dominate entire industries, while smaller competitors are simply priced out of existence. The privacy nightmare nobody's discussing here is something that should terrify you. Every humanoid robot is essentially a walking surveillance system. These machines are equipped with 10 to 50 cameras, microphone arrays, motion sensors, and constant network connectivity. They're designed to observe and interact with humans, which means they're collecting unprecedented amounts of personal data. Think about what a household robot actually sees. Facial recognition data for everyone who enters your home. Voice patterns and conversations, daily routines and behavioral patterns. Health indicators from how you move and what you eat. Financial behavior based on your shopping and consumption patterns. This makes smartphones look primitive in terms of data collection capability. Now consider that most of these robots are being developed by Chinese companies with unclear data governance policies. If 50% of American household robots are manufactured in China, what happens during a geopolitical crisis? The potential for remote shutdown, data weaponization, or activation of surveillance networks is very real. This isn't paranoid speculation. The US government has already banned TikTok over similar concerns about data collection and potential foreign influence. Humanoid robots represent a much more invasive form of data gathering with direct physical presence in people's homes. The cybersecurity implications are equally concerning. Robot hacking scenarios could include ransomware attacks where criminals lock you out of your own home, industrial espionage through household robots that observe work-from-home activities, or direct physical harm if robots are compromised and used to cause injuries. Currently, there are no established cybersecurity standards specifically for humanoid robots. The industry is moving so fast that security considerations are being treated as an afterthought rather than a fundamental requirement. What actually works versus what's just hype? Let me give you a reality check about what robots can and can't actually do, because there's a lot of confusion between marketing promises and technical capabilities. In the next 3 to 5 years, robots will probably excel at warehouse automation. This is already happening successfully. Basic food service like what we see at some McDonald's locations. Simple household maintenance tasks like advanced vacuum cleaning and lawn mowing. And elderly care assistance, particularly in countries like Japan, where demographics are driving adoption. But there are things robots won't be able to do effectively for at least another decade. Complex social interaction that requires real empathy, like therapy, teaching, or childcare. Creative problem-solving in unpredictable environments, like plumbing repairs or electrical troubleshooting. Most outdoor work where conditions change constantly, and any job that requires genuine human judgment and emotional intelligence. The cost reality is also important to understand. Current sophisticated robots like Boston Dynamics Spot cost around $75,000. Tesla's Optimus is predicted to cost $25,000 to $30,000, with annual maintenance running $3,000 to $5,000. For mass adoption, robots need to reach a price point of $10,000 to $15,000, and we're probably looking at 2028 to 2030 at the earliest for that to happen. This means that for the next several years, robots are going to be primarily tools for businesses and institutions, not household companions for average families. The companies making the biggest claims about immediate consumer adoption are probably overstating their capabilities. The geopolitical robot race. What is happening in robotics right now is fundamentally a geopolitical competition, and China is winning. They have several key advantages. Government funding of about $1.4 billion annually specifically for robotics development. Fewer regulatory restrictions on AI and robotics research. A complete manufacturing ecosystem that can rapidly prototype and scale production. And a large domestic market for testing and iteration. Chinese companies like Kepler, XSquare, UBTech, and Xiaosun are all making significant technical advances, while American companies are still largely in the announcement and demo phase. The US is over-reliant on Tesla's hype machine, has a fragmented ecosystem with little coordination between companies, faces higher labor costs that make robot development more expensive, and deals with regulatory restrictions that slow innovation. Europe is taking a different approach entirely, focusing on safety, regulation, and ethical frameworks rather than speed of development. Companies like PAL Robotics in Spain are making steady progress, but European strategy seems to prioritize getting things right over getting there first. The risk for countries that fall behind in this race is severe. Robot technology is going to be like semiconductors or internet infrastructure. Countries that don't control it will be dependent on those that do. And unlike previous technologies, robots have direct physical presence and capability, making that dependence much more problematic. Investment reality check. If you're thinking about investing in robotics companies, you need to separate the wheat from the chaff. Pure-play robotics stocks in China like Xiaosun Robot and Estun Automation have seen massive gains, 180% and 95% respectively in 2024. But these are established companies with actual revenue streams, not startups making promises. In the US market, Tesla gets robot hype pricing despite having limited actual robotics capability. Intuitive Surgical is probably a better bet because they have proven robotics revenue in medical applications. Japanese companies like Fanuc and SoftBank represent solid, established positions in industrial robotics and research. Red flags for investors include companies that only have demos without clear paths to revenue, those making overly ambitious timeline promises, and startups without clear competitive moats that can easily be copied by Chinese competitors with better funding and manufacturing capabilities. The bull case for Robotics suggests a $260 billion market by 2030, according to Boston Consulting Group. The bear case argues that actual adoption will be much slower than predictions, similar to what we've seen with autonomous vehicles. My personal assessment: the bull case probably applies to industrial and specialized service robots like Escape's massage systems. The bear case probably applies to consumer humanoid robots, which are likely to remain expensive toys for wealthy early adopters for several more years. What this means for regular people. So what should you actually do with all this information? First, don't panic, but don't ignore it either. The robot revolution is happening, but it's going to be gradual rather than sudden for most people. For individuals, focus on developing skills that robots can't replicate: creativity, emotional intelligence, complex problem solving, and interpersonal communication. Invest in education related to AI and robotics, even if you don't plan to work directly in those fields, because understanding these technologies will be valuable in almost every industry. For businesses, start small with pilot automation projects rather than waiting for perfect humanoid solutions. Build partnerships with robotics companies now while the relationships are still accessible. And most importantly, start preparing your workforce for transition rather than pretending it won't happen. For governments, this requires urgent attention to national robotics strategy, investment in technical education and retraining programs, and development of regulatory frameworks that balance innovation with safety and privacy protection. The countries and companies that take this seriously now will have enormous advantages over those that wait. The countries that don't, well, they risk becoming markets for other people's robots rather than participants in the value chain. The bottom line here is what I think is really happening. We're witnessing the early stages of a transformation as significant as the Industrial Revolution, but it's happening much faster and with much less public awareness or preparation. China isn't winning the robotics race because they have the best technology. They're winning because they have the clearest strategy and the fastest execution. While Western companies are still debating the implications and making regulatory frameworks, Chinese companies are building and deploying actual robots. The humanoid robots we're seeing now are primitive compared to what's coming, but they're good enough to start disrupting specific industries and job categories. And once that disruption begins, it accelerates rapidly. The question isn't whether robots will change everything, it's whether we'll be ready when they do. And based on the current level of public awareness and government preparation, most countries aren't even close to ready. But here's the thing: this is still early enough that individuals, companies, and even countries can position themselves advantageously if they act now rather than waiting to see what happens. The robot revolution isn't coming, it's here. The only question is whether you're going to be a participant or a victim of the changes it brings. What do you think? Are we moving too fast with robot development or not fast enough? And what should countries like the US do to catch up with China's lead in this space? Let me know in the comments. And if you found this analysis useful, make sure to subscribe for more deep dives into the technologies that are reshaping our world.